For our second lesson today on measurement, continuing the concept of accuracy and precision, is we're going to look at units and conversions. So I've got a question here. How tall are you? Or what do you weigh? And I want to know what comes to mind when you say this. So usually the responses I get when I ask these questions, and I'll give you my own, is how tall am I? I am 6 feet 2 inches. How much do I weigh? Well, typically somebody would ask, and I would say that I weigh 225 pounds. But why are we using these measurements? We do live in Canada at the moment, and Canadians don't typically use these type of measurements. In fact, I would say across the world, 95% of the countries in the world wouldn't use these measurements. We use the metric system. So why did we switch over to the metric system? Is because the metric system started in France quite a couple hundred years ago, whatever. It grew out of a need to have a standard system that everyone could agree on. Originally, what you'd have is something like this with the inches, dependent upon the king that you had at the moment. At any one time, an inch was originally defined as the measurement between the knuckle and the tip of the king's thumb. And so for particularly small kings, you'd have a small inch, and for particularly large kings, you'd have a large inch. And similar measurements went this way as well. Feet, inches, hands for measuring the heights of a horse, different things like that changed as we changed the king or the country. And so a couple hundred years ago, France comes along, and they decided to make this new standard units, which we use now called the metric system. But what they have is called the Système International. Okay, is a program of weights and measures based on the following standard units. So we're only going to go through a few of these, but as we go through the year, through the lessons, we'll see more and more of our standard units. Typically, we have length, and we use the meter. In the length of a meter, this is the actual technical definition of the length of a meter. In 1983, the speed of light was measured with extraordinary precision. The speed of light in a vacuum, defined as c, is now exactly 299,792,458 meters per second. And so we rejig that and we go backwards. And we say, well, the meter is the distance of light travels in a vacuum during exactly that time. It's not a very practical or useful definition, but that's not really what we're going for. What we need to know is exactly what a meter is. Remember, accuracy and precision. Another one I've got an example of here is mass, the kilogram. We use a kilogram, not a gram, but a kilogram as the standard. And there's this company out in the middle of France, and it's the International Bureau of Weights and Measures. And this company is immense. It makes millions upon millions of dollars a year. And the standard kilogram is a platinum iridium cylinder that they have guard over. It sits there on their desk, locked in a vault probably, and it has this exact measurements. It's approximately 39 meters, it's exactly, not approximately, but exactly 39 millimeters tall by a 39 millimeter diameter, so it's a cylinder made of platinum iridium compounds. And that's even still a little bit jiggly. They're a little bit more precise than that as we go through it. So these things are defined. Again, not very useful to us, but this is how we define it. How we can use these definitions, well, we're going to see some of that through our lessons. But mass, a meter, for length, kilograms for mass. We use time in seconds. We use A or amperes for electric current. We're going to see that quite a bit here in this class. And temperature, we use Kelvin. Another standard example here is we could use Celsius. In fact, most people use Celsius or centigrade as a measurement for temperature, but Kelvin is the actual best measurement for it. In order to make the numbers look more friendly looking, the metric system was defined. Okay, and the metric system uses a series of prefixes, which means comes in front of the unit, that tell us what we're doing. Okay, so for example, we have here a couple measurements here that we could work out, we got to watch out for. What we've got is the kilometer. A kilometer is 1,000 meters. Defined exactly as 1,000 meters. But when we're talking about the distance from Edmonton to Calgary, for example, we don't want to be measuring it in thousands upon thousands. Or later on in the semester, in this term, in this class, when we start measuring the distances between the planet Earth and the Sun, we can't be using millions upon millions of meters. The units are too big. So we define this metric system and we change the units by putting a subscript in front of the meters. So we see 1 kilometer is the same as 1,000 meters. So we got to watch out for that. We got to watch out for prefixes as they help us define what is the unit. Another one example is the picometer, size of an atom. We can't really define the size of an atom, so we need to know what a picometer is. It's a very, very small meter. How small? That's something we have to be able to be careful of. So we're going to do some calculations here, converting. In case you've never seen these before, some of them I know we haven't seen before, such as the picometer. We're going to do these together and we'll see exactly what the chart here next. This is a chart, so we can see now a pico. This is our chart of prefixes. So we can have a lot of different things here. This goes for any unit. So we could have a tera ampere for measuring current, or a kilogram for measuring mass. And we could have, again, a picometer, which is, again, it's times 10 to the negative 12 meters, which is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 meters. It's a very, very small value. We don't want to be writing all these zeros down every time I do a calculation. We can use our standard, our new units, pico, to make these measurements much, much easier. For the most part, we will be sticking around with these types here. It's always here on this lesson. You can always come back to it, refer back to it. A simple Google search will get these things too. Know exactly what our units are. Be careful, be aware, and know how to convert. So, a couple examples. How do we do a conversions from megameters into meters? So, on this lesson here, I'm going to show you one way to do it. It'll always work. If you've got other ways you've learned through other classes, be my guest, do those own conversions. But here we are with 45 megameters. And the way we're going to make our conversions is we're going to go back to that chart on the previous slide, and we're going to make that conversions. And we're going to say we're going to multiply here. And we're going to multiply, and what we want to watch for is whatever unit we have here, we're going to continue that in the denominator, megameters. And in the numerator, we are going to convert to what we want to make it. So we're going to convert to meters. So here's what we want, and this is what we have. And we make that conversion. We ask ourselves, how many meters are in a megameter? And that is 10 to the 9. So there are 10 to the 9 megameters, or meters, sorry, in a megameter. We can make this conversion, and we can multiply this across in our calculators, and we get 15 times 10 to the 9 meters, which for today in this lesson is good enough to leave it as it is. Okay. Another example here is to convert nanometers into meters, is we're going to do that again. 560 nanometers times. We're going to convert from nanometers into meters. Okay, so we're matching our new desired quantity. Meters is what we desire, starting with nanometers. A nanometer is times 10 to the negative 9 meters. So we make that multiplication. We see here the units, the nanometers disappear, and all we're left with is the meters. 560 times 10 to the negative 9 meters. If you wish, you could change that. You could put that in your calculator. For today, we're going to leave it just like this, as is, or for now, rather. Okay, a quick conversion here. Oh my, look at that nasty business. So now we're going to look at this value in meters, converting it to picometers. So we're sitting at 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 835 meters times, now in this case here, we want meters to go away, but we want the unit to be in picometers. So now we're going to solve this out, and we have to look that back up in our chart. And remember that 10 to the negative 12 meters, and that goes in the denominator. It sticks with my standard unit as my conversion. There are 10 to the negative 12 meters on my picometers. And now with this nasty business, we can plug that in our calculator. And really, if we work it properly, if we do your calculator properly, we should get an answer here of 835 picometers. Okay, we've got another lesson coming out on scientific notation, which will follow that and help that out, make that a little bit easier. Now we look at the last one, and I don't want you to fall into the trap of getting things too easy. I need you to be very careful when you're reading your questions. We're now changing kilometers into millimeters. So changing from 0.056 kilometers, what we're going to do is we're going to do two conversions. The first we're going to do is make it into meters and then go back to millimeters. This is how we're going to use our metric conversions, is we're going to do two conversions in order to get the new unit. First thing we're going to do is try to get rid of kilometers and take it back to meters, which is 1,000 times 10 to the 3. And then we're going to make my conversions from meters. So the kilometers are going to go away. And now we're going to move it into meters. And we're going to put meters in the bottom. And we're going to put my new unit, millimeters, on the top. And what we have is 10 to the negative 3 meters in a millimeter. Again, top to bottom, the meters is going to disappear, and we're left with millimeters. Now, how we're going to work this out, and I missed it above, is when we're dividing or when we're multiplying by things in the bottom, it's like dividing. So we're going to plug in our calculator. 0.056 times 10 to the 3 divided by 10 to the negative 3. Okay. Again, any other mathematics you've got to help you figure this out, can work this out easier. This is the way I'm going to do it, and I'm going to try to stick to it to make this easier. Okay, I'm going to give you one method, but of course there are lots of other methods to work this out. But we're going to come out here and we're going to get 56,000 millimeters as a final result. One last type of conversion we're going to work on here today, or in this lesson, is time conversions. These ones are a little bit trickier, but we have to follow that same procedure we did before, and we're going to work it out from here. First thing here, there's a typo I've just noticed. We're going to scratch that off, and we're going to go to years, and I'll explain to you why that is in a minute. So time conversions are always tricky, and this is up to you. You've got to know your rules. Okay, how many hours are there in 3.5 years? Well, we're going to look at this the same way we did before. I'm going to go to 3.5 years, and I'm going to convert. Unfortunately, I have no idea how many hours there are in a year. So what I can do is I can change that into another measurement that I do know. For example, years can be changed into days. 365 days. And we can make that same change now. I can cancel out my years. And now I'm going to go back to days. And I'm going to say days. Well, how many hours are in one day is 24 hours. So now we can work this out and we can solve this. 3.5 times 365 times 24 gives us 30,660 hours. Okay, we can go that backwards now. We can do the same example. And the reason, why would I change this from minutes to years? Instead of talking about months here, months is always a bad one. A bad one because every month is a little bit different. February has 28 days, March has 31, April has 30. Every month is a little bit different. Harder to calculate how many days are there in that month. But we can go backwards and we can do this now. Let's take about years. You can argue how many days are in a year. There are leap years, etc. Let's ignore that just for today. while we're understanding how to do the conversions for now. Okay, so what we have here is 394,727,938 minutes times, we're going to get rid of the minutes, and we're going to turn that into our next favorite, hours. There are 60 minutes in an hour. At 60 minutes per hour, we can then keep going up and up and up until we get the proper units we're looking for. Hours into days. Again, there are 24 hours in a day. And then finally, we can move it back up into from days to years. And there are 365 days per year. And we can see all our units. Minutes goes away. Hours goes away. Days cancels out. And all we're left with is years for my final answer. So we're going to take 394,727,938 divided by 60 divided by 24 and divided by 365, and we get ourselves approximately 751 years. Watch out for some of the weirder units, decades, centuries, etc. It's all about managing your fractions, guys. It's multiplying and dividing, making sure you can do these conversions. Follow through on some of this. We've got some questions coming on this for you to practice before you get to the quiz at the end of the day. We've got one more lesson coming up on significant digits and scientific notation.